left side went to the right side. So it's actually, a mirror image is not exact. And that's the reason that when we have, like, let's look at our hands. These are essentially like the mirror images, but they are non-superimposable. You cannot overlay them, okay, because then the thumb would be on the other side. Okay. We cannot do that. We can only do it this way, but that's really the mirror image. And that's why, obviously, the right hand glove doesn't fit in left hand, and your right shoe wouldn't fit in your left foot. So these are mirror image structures, because essentially because we are kind of symmetrical, that's why the mirror image sort of looks like us, but it's not really the exact thing. If you have a mole on your right cheek, it ends up in your left side of the mirror image. So this is really relates to the chirality, that our hands are essentially chiral. Okay. This hand cannot be superimposed with this one. And that's also true for molecules. In the molecule, let's say if you have, let me show you a molecule. These are essentially mirror images. Okay. These two are mirror image structures. Right? We have 4 different groups attached to them. Blue, red, green, and this one has nothing. Right? Anyway, so these are mirror images. And now let's try to superimpose them. If we superimpose 2 of them, the other 2 are not going to fall on the side. So they are not identical. They are mirror image structure, nevertheless they're different. And that's essentially what the non-superimposability, that's the definition of chirality, which means that both these molecules are chiral. Non-superimposable with its mirror image. That's what the definition of chirality is. And obviously the achirality means if we now change one thing, let's say we add 2 greens to a molecule. Now we have 2 greens, and now see if we do this, they overlay, they are superimposable. Right? So they are exactly falling into each place. So now this is a chiral molecule, this is an achiral molecule. So achiral means superimposable with its mirror image. So in nature also we see many things that are either chiral or achiral, depending on the object there. And there are some special property to this. The mirror image, when it's non-superimposable, they actually are different compounds, even though their connectivity and everything is the same. Okay. So when they are chiral compounds, that are mirror image structures but non-superimposable are called enantiomers. And so the first compound that I actually enantiomers. So these two are therefore mirror image structure but not superimposable. So these two are enantiomers. Okay. And the compound would be therefore stereoisomers. They are one type of stereoisomers. So what kind of compound are they? To give you an example, let's start with a very simple molecule. Let's say 2-butanol. In 2-butanol, we have actually 4 different carbons. But what is the important one is to figure out that this particular carbon has 4 different groups attached to it. Right? It is attached to a methyl group, an ethyl group, a OH hydroxyl group, and a hydrogen. So 4 different groups attached to this carbon. Carbon 2. That one has 4 different groups attached, and therefore that is a chiral carbon. Which means that we can draw 2 different structures of this compound, and they would be mirror image structures. So in 3 dimensions now, let's say you have OH, CH3 and CH2CH3. And the mirror image structure, and you can write it in any which way you like, but the mirror image structure would be exactly like this. So these two are therefore enantiomers. Okay. Now, in terms of their properties, it turns out that if we take either one of those two and essentially list their properties, they're almost nearly identical in every aspect, except one. They have different optical activity. And in the next class, I'll describe what optical activity is, and then go from there and describe other types of chirality related issues. Okay? So I would ask you to first read through the first few pages, first few sections of chapter 7. That will make you understand it much better. Okay? Questions?